giving name demo. Okay. Yes, it is by default open in drawing. Simple click on OK. And this is the different kind of title and different kind of model layout. You can select as per your requirement, but for the time I'm just selecting the default. Here you can see default, it will show different view palette. That means it will give you the different front view, top view, right side view, automatically. And you just need to drag and place it over here. And after placing, not only that, you can create different dimensions or different projection view as per your requirements. See, as I am creating the different projection view, that also you can do. Just a second. See, different isometric view also, if you want to draw, that is also possible. And not only that, if you want to change its visual style, that also you can do. So this is how, by using SolidWorks, this particular syllabus is very much easy to complete, that advanced CAD and engineering. Okay. Now, coming to the next, mechanical engineering. See, this is a particular subject which is there for a 3 branch, that mechanical, automobile engineering, aerospace engineering and other mechanical. Third step, here you can see what is the content. So you just need to create engineering drawing, because for any kind of designing, engineering drawing is the first one. Okay. But after that, you just need to create this bolt and nut, thread, cutter joint, knuckle joint. These are the things you need to create using the software. Okay. So let me show you that how easily you can draw this kind of model also, because I am here just showing you the example of single component, but all other component also you can create very easily. As you can see, knuckle joint is there, simple screw jack is there. All the component you can design very easily, only using, and only what is the requirement? Only the requirement is the dimension, how to create that particular design. Okay. So you can see, this is the simple screw jack what I made, which I already made using this SolidWorks platform. And not only that, you can see I already created all the individual parts. I already assembled them, as well as I can simulate them. I can going for the SolidWorks motion as well, so that your student can very easily understand that how it is going to work, how it is going to work in the real life after the completion and after the real life manufacturing of a screw jack. What is the role of a screw jack? How the screw jack is going to work in real life. Okay. So this is the animation video, but I just want to show you that live, that how that screw jack is already. I already made that drawing. Just a second, I'm going to show. This is not required. Okay, screw jack. Yes, this is the assembly which I already made. I just need to simple drag and drop. See, this is the total assembly of our screw jack, and very easily you can do the same as I already show you the part modeling. Like that, you can go for that assembly as well as the drafting of your component as well. And not only that, after the completion of your assembly, you can create your exploded view as well. So what is the main benefit of exploded view? You can visualize your component in a better manner, that which component is going to fix and which component is going to fix at which location, so that you can identify that whether my assembly is correct or not correct, so that you can make your design changes accordingly. So this is the beauty of exploded view after the completion of your assembly. Okay. So this is one example. So now I am just going to show you one more example. So let me going back to my presentation. Okay. So this is one example which I already show you. Now I am going to show you one more example, that is knuckle joint. You can see. So whenever you are going to design something, you will get all the dimensioning and detailed drawing, because for understanding all this sectioning view and different kind of view presentation, you just need to clear the concept of your engineering drawing first. So for the timing, you can see this is the different part of our knuckle joint, and all the parts are having its different annotation view and a dimension as well. Okay. So let me show you that how easily you can create the same component of your knuckle joint. And for the time being, I'm just showing you how to create the individual part, each not possible to create individual part, but I'm just going to show you one part of knuckle joint and how to assemble them all together in a single environment. Okay, so you can see that. So it's all started with the 2D sketches like I already show you in my previous slide. So you just need to create a 2D sketches, and after the completion of your 2D sketch you need to apply some kind of 2D constraint. Okay, so that your sketch must be fully constant. You need to apply some kind of dimension to that. See, this is your base sketch. So after the completion of your base sketch, what we need to do? We just need to add material to the base sketch so that it is converted our 2D sketch into 3D model. Okay. So after the completion of your 3D model, you need to perform some kind of different operation as well. So for the sake of time, I'm just keeping little bit so that you can understand that how easily you can draw something in a single environment. Okay, so by looking to that, you can see the detailed drawing of the C section it is given. You can convert that, you can represent the same thing in the CAD model, and after the completion of that thing, you can see it is going to look like this, the fork end, the one of the part of our knuckle joint. Okay, yes, this is the detailed portion of that C. Now see, this is what your design is going to look like, but suppose you want to change the appearance, that also you can do very much easily. As you can see, the steel is there, chromium is there, bronze is there. These are just the different appearance, and you just need to drag and drop your appearance to the Solidworks environment so that it is going to look like very realistic image. Okay, in the Solidworks environment, which will look very much beautiful at the time of designing and drawing. And you just need to save your individual component like that, and finally we can going for that assembly. As you can see, all the different other parts are also created as I show you previously, and it's time for that assembly. So you can see this is the assembly environment. You can call individual part to this assembly environment one by one, or at a time also you can call. And after the calling of all the individual part to this assembly environment, very easily you can going to add them or fix them together at its required position by simply applying the mate. Here it is known as mate. Okay, mate is basically known as the constant for the assembly. So you just need to select one circular face of this base part, then another circular face of the other part, and if required you can move your component or you can rotate your component. You can see both the circular faces. I just need to select, then I just need to click on mate. So it will open a window like that. You just need to select that circular face, this circular face. So both are going to be add a relation that is concentric. Okay, so again I'm just going to apply one more constant, that this particular face is going to coincide with the lower side of this fork end. So it will automatically take coincidence, and now it is only free about its one axis, that is y axis, so that it can be rotated only. So how can we restrict that thing? So for that reason, what you can do, you can select that particular face and fork end face, and you can apply coincidence or parallel relation. So now this is fully constant. So in the same manner, what you can do, you can apply the constant within all other parts, and finally you can complete your assembly. And the same manner it is completed as I already showed you for the first two parts. In the same manner you can apply for all those parts. It is finally completed. And after the completion of that thing, as I already show you, that you can wait for the creation of your extruded view. So that what is the benefit? As I already show you, that you can see that, you can visualize that which component is going to fix at which position, so that in future if any design modification required, you can visualize it properly and you can understand and you can make the design changes as per the requirement. But it is not only that, because as I already show you, it is not limited to design only. It's time for the checking the design validation as well. So For the timing, I'm checking to the Solidworks Simulation as well, so that you can understand that using the same platform, same Solidworks software, you can going for the simulation as well, so that you can understand that see, this is a circuit, it is designed by you, okay, but in the real life, it is going to work in a certain environment where it is going to undergo different kind of external pressure, external load, external stress. So how this part is going to react towards all those external factors. So you can simulate that one and you can visualize. So that at the design stage only, you can make your design changes so that your design is fit for that market. Okay. So in a single environment, your requirement you can after the creation of your design, you can apply different kind of material to use and different boundary conditions, like where which end you are going to fix, at which end you are going to apply the external load like stress or strain or any kind of force or pressure. That means you can see this part I am going to fix. That means it is going to fix. I am going to apply the external pressure from the top side. So that also I can do. You can see here force. I am going to apply the force from the top side. So I just need to select the top face. This particular face. And here I just need to define how much force I am going to apply. So for the timing, suppose it will be 200 Newton. Okay. So this is my boundary condition. It is already defined by me. Now I'm going to mesh it. So what is the need of mesh? So meshing is basically what it does. It will discretize or divide my total component to number of small components. So which will increase my ability to get a proper solution. Okay. So the coarse or fine. So what is the mean? If I am going for the fine mesh, it will take more time to solve, but it will give my accurate result. Okay. So after a small time, you can see after the completion of your meshing, your component is going to look like this. And this is the result. So what is the result we get over here? Stress, displacement and strain. So not only that, you can simulate and as well as check. Displacement means, so this is my boundary condition. So after applying this amount of force, 200 Newton of force, my part is going to bend like that. Okay. And beauty over here is in the SolidWorks that you can create the report of your simulation. That means you can save all your data. That means whatever you define, that what is the boundary condition, what is the load, what is the boundary type, what is the material type, all data you can save. And finally, it will record all the data and then it will give you in terms of an MS Word, so that you can share with your other colleague, other student, and you can attach it and you can record it as your design file as well. Okay. So this is the beauty of the particular software. Then strength of material, as you can see, so this strength of material is very much essential and common for all the three types of department. Here basically what it does, we used to create some kind of stress, shear force and bending moment diagram, which is there in your syllabus as well. So how easily we can create the same shear force bending moment diagram in the SolidWorks as well. So as you can see, so we can create the same part. So it is very much easy to create the part, as I already show you how to create the part, but I'm just straightly taking to the stress strain curve diagram. Okay. So as I already show you in the previous video, that you just need to import, you need to define boundary condition. So as this one is a simple cantilever beam, I just need to fix one end and the other end will be free. So that after the completion of defining all the boundary condition, you can see, you can create a shear force like this. So for a simple cantilever beam, shear force is going to look like this. Then you can create the same bending moment for the same thing as well. And not only that, see, you can create the stress strain curve as well. That means depend upon your parameter, depend upon your stress strain value, it will give you the result as well. So that here we are just showing you the stress strain curve, but for any kind of component analysis also, that time also it will be very much essential and beneficial. So now it's time for creating the bending moment for the same diagram. So same boundary condition. See, this is a bending moment for that. Okay. So this is how very easily you can showing, because previously what we used to draw our shear force bending moment using our whiteboard or blackboard, but using the software also it is very easily to show to the student. And this is how it is showing you how easily you can create the report of the same thing, which I already show you previously. Then coming to the Cad Cam Lab, which is there in our mechanical engineering 5th sem. So what is the use of CAD and how the varieties of different tools, different features are there, using which you can create different very beautiful CAD model, which I already show you. But it's time for that CAM now. So basically CAM stands for computer aided manufacturing. That means using SolidWorks you can go for that virtual manufacturing as well. So why it is essential to learn virtual manufacturing for the student? Because what happens whenever we set our student to the workshop, so before going to the workshop they should understand that what is the lathe machine, what is the milling machine, what are the different machining parameters, what happens if they make some changes to the machining parameter like cutting speed, depth of cut. Okay, so they should understand that. So this is how, and this is the area where that SolidWorks gives you the flexibility, that is the student can create their CAD models, they can create going for the virtual manufacturing as well. Okay, so that they can do their all their mistakes in that software only, so that it will not going to hamper to your machine or any damage to the student as well. Okay, this is the benefit of the CAM. So in the CAM you can see here I am just going to show you the turning. Sorry. So you can see this is the model. So very easily this kind of simulation or this kind of virtual manufacturing you can do by using SolidWorks camera. You can see the single point cutting tool is coming. It is performing the fetching operation first, then turning operation, woody turning is there. So this is a simple example, but apart from this complicated kind of example, the simple machining, that milling machining, your turning machining, both you can do by using the same environment. So what is the benefit over here is that, so designing is very much flexible, as I already show you different a number of times. Now, what else thing? So here very easily you can define different as your desired machine. Like you can say that milling is there, but for the timing I'm just selecting the turning as my operation. So after defining the turning operation, what it does, the SolidWorks automatically extract all its machinable feature. That means you don't need to define all the feature manually. As you can see, it is automatically added material or stock to for that particular component. Okay, so you can define and you can edit your component, you can define your desired raw material for your machining. Okay, all the parameter you can change very easily as per your requirement. And finally, when the machinable feature is extract, you need to generate the toolpath. You can see the face roughing, that turn roughing, as well as roughing, as well as the finishing operation. It will create by its own. And not only that, after the creation of all these toolpath, you can make changes to that as well. As you can see, this toolpath is created, but suppose you need to make some changes to that. That also possible. That means software automatically defines some kind of depth of cut, and you just need to, suppose you need to make some changes to that depth of cut. That also you can do very much easily. Simple, you just need to click on edit definition. It will give you a pop-up window where you can modify all your desired parameter. You can see over here, this is that particular window, the feed and speed. So what is the feed value, speed value, turns up, what is that angle, and what is the first cut action. Then all your machining parameter you can define very much easily. And after defining all sorts of things, you can go for that virtual manufacturing. You can see how it is going to affect your machining. And until and unless you are not satisfied with the result, you can keep on modifying and keep on changing. And once you are satisfied with the result, you can simply create G code and M code, which is very much essential for running of our CNC machine. As you know, our CNC machine is only run through our G code and M code. Okay, so this is where the SolidWorks plays very much essential role for the CAM as well. Then the grasp flow, because in our syllabus one kinematic links are also there, like where what is the grasp flow, that the combination of the addition of shortest link and the longest link, which less than equal to the other. This is the rocket thing. So for that complete rotation, what is our requirement? Our rotation for the complete rotation, our requirement is that addition of this one, this two, this distance and the here to here, this distance should be less than equal to total distance between these two components and then these two components. Okay, so that also I'm going to show you that from here to here, what is the dimension, that also you can see. So which is, so that means student can visualize whatever we taught them. They can visualize it in a better manner. And as you know, if student visualize the concept, they will understand the thing and it will be there in your mind for forever. Okay, so this is how you can do all the sorts of things. And finally you can see that, so for the complete rotation, that is the, that law is satisfying. Okay, now, so this is all about for the mechanical, but SolidWorks also not dedicatedly for the mechanical. In terms of your electrical engineering also, SolidWorks plays very much essential role. As you can see, that electrical drawing subject is there. Okay. Here you can see that wire diagram, control system. That means different electrical 2D circuit diagram is also there in your syllabus. So using SolidWorks, you can draw all sorts of circuit diagram as well. So there one model and one platform is that our SolidWorks electrical. So using SolidWorks electrical also you can draw the 2D layout for all your individual component, individual models, the circuit diagram, all sorts of work you can do very easily. As you can see here, the 2D layout. After the completion of your one, you can mirror it, you can pattern it, so that repeatedly number of times you don't need to create. And not only 2D layout, but also the in terms of your 3D also, you can do that one very much easily. You can see this is the total control panel. That means suppose you want to identify which is suitable position for placing your component, that also you can find out very much easily. And after find out in the proper position what you want, you need to create the route for that. So using SolidWorks you can vary it, means routing also possible using the SolidWorks electrical. So that means this is a complete package for the electrical student as well, so that using a single environment or single software, they can create their 2D layout, they can create their 3D diagram, and they can lay out their particular thing in a single environment. And after all, they can print it in a 2D sheet as well. Okay. Which I already show you. But now it's time for that SolidWorks simulation. So as I already show you, or not only the design, it's also required, it's also necessary to check whether our design is validate or not. For that reason, SolidWorks is also very much essential. Then coming to SolidWorks plastic. So SolidWorks plastic means, as you know, there is a, in the manufacturing production or production technology subject, there is a one subject is there, mold. Okay, so in the mold we used to go for that the plastic. So SolidWorks also having one more its module like SolidWorks plastic. So where you can go for that extraction of your core and cavity for individual component, and just to show you the student that yes, this is the core part of your particular component, this is the cavity of the particular component, so that they can understand that yes, as we know, as we all know that the core is responsible taking care of the internal feature of our component, and cavity is responsible for the taking care of the external feature of our component. So that is also possible through the SolidWorks plastic. Okay, that is the Simulia video which I already show you related to the SolidWorks simulation. Okay, now SolidWorks MBD, why it is very much essential? SolidWorks MBD is basically what happen, as I already show you. You can see in that image as well that the GD&T symbol, the surface roughness symbol, all are these are the notation and the annotations are also there. But repeatedly what we are using, you are using this kind of symbol only in our 2D sheet as well. But by using the SolidWorks MBD, you can define all sorts of application in the 3D model as well, so that at the time of designing only we can define, we can show to our student that yes, this is our 3D annotation. That means this particular face is going to coincide with this particular face. This face must be perpendicular to this particular face. So without going to pre-drafting, that also we can deliver and we can make them understand to our students. Okay.
Solidworks MBD helps companies define and organize product and manufacturing data, or PMI, including 3D model data, and publish to industry standard file formats. With Solidworks MBD, dimensions, nodes, and symbols are automatically placed on annotation views, and 3D views can be used to organize 3D PMI in a structured, easy-to-locate fashion. In SolidWorks 2020, individual annotations are now listed under each annotation view to help visualize the relationship between annotations and the view on which it was assigned. When you select an annotation in the Feature Manager, it's highlighted in the Graphics area, and annotations can now be easily hidden or shown. The names of the DIM Expert annotations now follow a new format, which adds the feature name and dimension value to the previous format. By default, annotations appear in subfolders that correspond to the view to which they belong, but can also be sorted by annotation type, such as dimensions, datums, nodes, and symbols for better organization. With SolidWorks MBD, companies can capture all of the required PMI to guide the manufacturing process directly in 3D, helping to streamline production, reduce errors, and eliminate traditional 2D drawings.
Now coming to the Solidworks visualization, so this is very much essential, because what you did, you already have your concept, you already created your 3D model.
ए समस्या से लिंक रे जॉइन करी कि सॉलिडवर्क्स टा देखो समस्या
validate or not, yes, that is validated
क्लासरूम में था
from the CAM. That means how your component is going to created, how your component is going to manufacture. That means you already go for the CAM as well. That means your component is now ready to manufacture. But what about the visualization? That means after the creation, after the manufacturing of your component, how it is going to look like in the real world. So there the SolidWorks Visualize comes. So using the SolidWorks Visualize, you can create photorealistic rendering so that you can visualize how your component is going to look like in the real world. So have a look on that.
अरे ठीक से जाओ सी रसो फर्स्ट ईयर पिला आसबे ना जल्दी
What does it take to bring your design work to life without manufacturing a single part? It takes SolidWorks Visualize. SolidWorks Visualize is a camera for your CAD data and helps you leverage your design work to create photographically true visualizations directly from your CAD model. Utilizing the industry's most powerful ray tracing engine, painting your model with accurate materials is easy. SolidWorks Visualize real-time photo-accurate results virtually eliminates guesswork, giving your customers a deeper emotional connection with your designs. Exploring different aspects of your product's persona is simple. SolidWorks Visualize is capable of telling a deeper story that resonates with your end users and key stakeholders. Generating the visual content that captivates is easy to create, whether it's for a website, presentation, product video, or advertisement, and helps drive interest toward the products you envision. SolidWorks Visualize has the power to bring great designs to life and compel your audience's attention, all from the convenience of your CAD data.
These are some of the few examples which is already created by SolidWorks Visualize, so that you can create this kind of rendering, this kind of picture as well. And not only that, you can see the same component is there. It is a biotap model processing lake. Okay, you can see the component is same, but different color combinations are also there. Okay, so that also you can create, and you can decide that yes, this particular color is going to is suit for my component. So I'm going to manufacture it by using this particular color. Okay, so that before manufacturing you have one option just to show just to see that how your component is going to manufacture and how it is going to look like. Not only that, you can create this kind of very
କ୍ଲାସରୁମ୍ ବସିକି ସଲିଡ୍ ୱାର୍କସଟା ଦେଖ।
attractive animation as well, so that you can see that yes, all these are my component and it is going to fix like this. So this is the role of a SolidWorks visualizer. You can see how the rendering, how the animation occurs. It's combining all the exploded part to the single environment. It collects all your exploded part it's going back to its desired position. All the nut and bolt, all the other parts. That means SolidWorks is the complete package for each student and each individual student, not only for that but also for the teaching professional as well. That means using a single environment you can create your 2D sketches, you can convert your 2D sketches to 3D, you can create that drafting of your individual component, you can create that assembly, and you can going for the manufacturing, virtual manufacturing, you can go for the design validation using SolidWorks simulation. That means this is a complete package. That means if a student learns SolidWorks, so he can add very much added advantage. He can add number of skill to his career, number of added value to his CV, so that whenever he is going to pass out from a particular organization, he can place himself in a better position for our real job scenario. But
Yes, Amit, you can continue.
Yeah. So as I already discussed about the thing related to SolidWorks, now it's time for the additive manufacturing. So as you already know that this is a trending topic, that additive manufacturing. We are talking about additive manufacturing, but everyone we know this one as a name with a different name, that is 3D printing. But the concept behind the 3D printing is known as additive manufacturing. This is the area also where SolidWorks is going to play, and it is already playing very much important role. That means I already show you different features, different aspects of our SolidWorks. But in the 3D printing also SolidWorks contributes. That means not only you can design your component in the SolidWorks, you can also go for the 3D printing as well, for using the same SolidWorks environment. So have a look on this video so that you can have a better idea.
Solidworks 2020 includes a comprehensive list of 3D printers with up-to-date envelope information. Quickly browse or search for your most used printers and add them to the favorites list so you can quickly access them from the drop-down menu. Selecting the face that you'd like to orient towards the substrate will show the printer's envelope and highlight geometry outside of the print area in red. Let's raise the part and then have SolidWorks find a suitable orientation. SolidWorks 2019 gave insights into faces that require supports, as well as striation lines based off of a user-defined layer height. With SolidWorks 2020, you can now generate slices based on precise 3D geometry, rather than having to first export to a tessellated geometry format like STL. This information can be saved in the 3MF format, an open-source XML-based format designed specifically for modern additive manufacturing. It not only stores the 3D geometric data, but also stores material, color, textures, to be sliced data, and more. If you don't have fabrication resources available in-house, try 3D Experience Marketplace Mate, where you can get quotes from hundreds of qualified service providers and several different manufacturing processes at the click of a button. You simply upload your design, optimize it live, choose your manufacturer, and receive your custom part. With all of these new 3D printing enhancements, SolidWorks 2020 is making it even easier to go from design to prototype to manufacture.
ଏବେ ମୁଁ ବା ଏଠି ଅଛି ସେ ଯୋଉ ଇଏରେ ଅଛି ତ ସମସ୍ତେ ପ୍ରିନ୍ସିପାଲ ମିନିଷ୍ଟର ସମସ୍ତେ ଜଏନ୍ କରୁଛନ୍ତି ନା।
That means what is the concept it is showing that
ହଁ
you can see. So basically 3D printing means our
ଆଉ ତାଙ୍କ
material,
ନାଁ ଦେଖାଉଛି।
our final component is going to created by adding
ସିଏ
material
ବୋଧେ
layer
ଜଏନ୍
by
କରିକି ଛାଡ଼ି
layer.
ଦେଇଥିବେ ବୋଧେ ଆଉ।
So
ହଁ
have a look on this
ଆଜ୍ଞା
video so that you can understand that how your component is going to added layer by
ହଁ ମୁଁ
layer
କରିଦେବି
using our 3D printing technology.
ଆଜ୍ଞା। ଶୁଣ
Now it's time for that certification. We already discussed some of the number of features, some of the important aspects, some of the required feature, important feature of SolidWorks. But why this SolidWorks certification is also important? Why? As you can see, the first line, what is the SolidWorks certification can be used as a benchmark. That means whenever after the completion of your college or after the completion of your course, whenever you are going to apply for a job, how that interviewer person can identify that whether you know SolidWorks at what level. That means you know SolidWorks, I know SolidWorks, but what is the parameter which differentiate between you and me? So that is the SolidWorks certification. That means there are basically 3 levels of certification: associate level, professional level, and expert level. So this is how you can set your position so that that particular interview can identify and he can understand that yes, if the student is at professional level, he must know all these are the things using SolidWorks. If he is in the associate level, he can understand, he should know all these things related to associate level. Okay, so this is what that SolidWorks certification is very much essential. And the 3D experience certification also available now. So have a look on this video so that you can clear that wow, SolidWorks is very much essential for the student, not only for the student but also for the faculty or for the teaching professional as well.
When you need something done right, you want a skilled professional. But how do you know they have the right training and the competency to properly apply that training? Making the wrong decision can cost you time and money, and you still haven't met your need. So, what about SolidWorks? As an instructor, you want your students to graduate with a good education and job-ready skills. But how do you prove your proficiency as a SolidWorks instructor? And get the job of your dreams. And whether you're an instructor or student, how do you know you've learned the material? Enter SolidWorks Certification. SolidWorks student and instructor certifications give you a benchmark to verify knowledge and skill with SolidWorks software. With SolidWorks Certification, you can easily demonstrate your expertise to the SolidWorks community, show your dedication to professional development, and put yourself ahead of your competition. The SolidWorks Academic Certification Provider Program is an industry-standard engineering design competency program that gives students and instructors a competitive advantage and a way to demonstrate their expertise with SolidWorks. As an added bonus, students can take these exams free of charge when their school is a certification program provider. SolidWorks Certification, innovative and effective learning, industry-standard accreditation, the skills and expertise to do the job of your dreams. To learn more about SolidWorks Education Solutions, contact solidworks.education@3ds.com or your local value-added reseller. or visit our website at www.solidworks.com/SWEDU-certification.
Now, as I already told you, these are the certifications that are available. But why these certifications are important? So it will give you a better job skill, and this SolidWorks certification is recognized by globally. That means not also in the India, but also if you going to go abroad, there also they can recognize your certificate. So depend upon your SolidWorks certification, they can hire it. So this is the beauty of SolidWorks because it is globally accepted, and SolidWorks is not only popular in India but also globally. So this is the beauty. And there for the starting level, for the student level, or for any kind of teaching professional, there are more than 11 additional exams. That means for the entry level, the first certification will be CSWA, then CSWP, but there are individual, there are different more than 11 certifications are also there. Even I am already completed my 18 number of certification till now, but still I need to complete. So that means this SolidWorks certification will give me a booster. And for a tip for everyone is that whenever you clear any kind of SolidWorks certification exam, your data will be saved in their uh, server for the lifelong of the Dassault system, that this particular student or this particular personnel cleared our this particular certification program. So this is the beauty and this is the benefit of the SolidWorks certification. Okay. Now for the summary and key takeaway, I just want to call my colleague Rita, please. Going for
Thank
that.
you. Thank you so much, Amit. That's one of the wonderful session I have ever heard. So let's take some summary, takeaway what we have learned in this webinar. So we have a very powerful system where we can like make use of this SolidWorks and shape our skills to get industry-ready jobs. So it's a environment. SolidWorks is an environment where we can do our CAD design, modeling, 2D, 3D, and we can also teach our students. Educators can use this platform to teach their students for their better visualization, for the practical implementation, and whatever the things are there in the syllabus, where they will use this knowledge in the practical world, practical implementation they can also understand. Okay, and beside this, if any students wants to get a job in this pandemic situation, okay, so then what will happen? Now the world has changed. The conventional way of getting a job or conventional way of jobs has been changed, and now every mechanical engineer or anyone who wants a job, there is a vast area where we can have a good job. If you want to see how much jobs are available, just go to any portal, any job portal, just type SolidWorks and you will see more than 4,000 jobs across India, across global. So these are some of the skills which are very easy to learn and very easy to get a job, a good job. Okay. Next slide, please, Amit. So, if there are any questions.
Sorry to interrupt, I just want to add a few more points over here. So, as we already discussed, there are